consider the question. Here the question is, for the given Bayesian network and probabilities, generate the conditional probability table. We have to generate the conditional probability table. The given Bayesian network contains 4 nodes. Those are A, B, C and D, and there are directed arcs between them. And they have given the probabilities, and we need to compute the following probabilities such as P of A by B, P of A by B comma C. We need to find the joint probability, that is P of A comma B comma C comma D. Firstly, we shall find the answer for this question. So now in the question they have mentioned that we need to find, this is a question, and they have mentioned that to find the conditional probability table. First we need to find this conditional probability table. So first draw the network A, C, B and D. These directions are very important. Here B is dependent on A, C is dependent on A, D is dependent on both A and B. Now B is dependent on A, right? So A, we need to find probability of B. For A, for single condition, for single variable, there will be 2 conditions, whether A can be true or A can be false. So here in the question they have given probabilities, right? So here P of A is 0.4. P of B, if A is true, then probability is 0.5. P of probability of B, if A is false, is 0.1. These values should be written here. So P of B, if A is true, the value is 0.5. And next, P of B, if A is false, then 0.1. The value is 0.1. Because B is dependent on single variable, therefore it has only 2 conditions. So here D is dependent on both variables A and B, right? D is dependent on 2 variables, 2 nodes, those are A and B. So let us draw a table for D. D is dependent on 2 variables A, B, P of D. So for 2 variables there must be 4 conditions. Those are true true, true false, false true and false false. From the question itself we can find the answer. We are finding the probability value for D. So probability value of D, if A is true and B is true, there is no negation symbol, it means both A and B are true. Probability of D, if A and B are true, is 0.8. Both are true, then the value is 0.8. Probability of D, if A is true and B is false, here there is a negation symbol, it means that A is true and B is false. A is true and B is false, then the probability value is 0.3. If A is false and B is true, here see, A is false and B is true, then the probability of D is 0.3. Which I will write here. If probability of D, if both A and B are false, here you see that, you can see that Probability of D, if both A and B are false, then the value is 0.05. We are done with probability values for D. Now, C is only dependent on A, right? So, you can find the probability of C value with only A. Probability of C. A can be true or false. Again, probability of C if A is true is 0.6. Probability of C if A is false means 0.3. We write these values here. 0.6. If A is false means 0.3. Okay. Initially, A is not here. A is not dependent on any node. It is an independent node. So, the probability of A is 0.4. Let us construct a table. P of A is 0.4. These are the values obtained. So here neatly we will write the table in a table format. That is, firstly, P of A value is 0.4. A can be true, false. By A we can get the probability value of B. So therefore, probability of B if A is true means 0.5. Probability of B A is if A is false means 0.1. Now probability of C if A is true means 0.6. Probability of C if A is false means 0.3. Now A and B values are to be obtained: true true, true false, false true, true true. P of D can be calculated by using both A and B nodes. So these are the values: 0.8, 0.3, 0.3, 0.05. This is the conditional probability table for the given Bayesian belief network. Hence we name it here conditional probability table.